Hi dear students, in this video we will discuss about question number 10 onwards of miscellaneous exercise and chapter number 5 is there and class 12th. You know what we did in question number 1 to 9. I tried to give you simple explanations there and now we will start our next calculation work from question number 10. Here again the work is same. You have to find its derivative with respect to x. So as we marked earlier in all the previous questions, we have to write in this way: let y equal to x raised to power x plus x raised to power a plus a raised to power x plus a raised to power a. Remember students, this a is a real number and here also power of a given like this. Okay, if you have 2, you can mark it as 2 raised to power 2. Only a number, and you will get a number, and you know derivative of a number is always 0, means derivative of a constant value is always 0. So keep in mind this value. Okay, so let me tell you now how to write it. So we are going to write derivative. So I am writing differentiating with respect to x. It will be dy upon dx as you mark always. Then here d over dx of this first statement given x raised to power x. Similarly for all we have to write. I am writing for all d over dx means derivative. Symbol of derivative, it is a raised to power x. In the end, derivative of a raised to power a. So we have this. It is clear last derivative will be 0. And what about this? It is d over dx of a raised to power x. Directly there is no possibility of calculation here. So I am writing it as same. Okay. But what about this x raised to power a? It is like x raised to power 2. And you know how we write derivative? It can be written as power in front of this and power of x will decrease by 1 and then derivative of this x. It will be 1. The same meaning is here. We will write its derivative as a in front of this x raised to power n minus 1, or we can say a minus 1, and derivative of x is 1. Next, you can't find its derivative directly, d over dx of x raised to power x. Function in x and power also in x. So we have dy over dx equal to this value. Further, we will write it as let. This is actually okay. This one, the x raised to power x is suppose u, and this one will remain same, ax raised to power a minus 1 plus. What about this d over dx of v, where you can mark u is x raised to power x and v is a raised to power x. So this is dy upon dx. Mark it as 1. So you need two answers, du over dx and dv over dx here. So right now u is, you mark there x raised to power x. Take log in both the sides. So right, taking a log in both sides. When you write log of both sides, it will be log of u equal to log of x raised to power x, or log of u, this power of x will come in front of this, it is x log x. So I will write some steps here. Okay, so it is log u equal to this, mark them as first and second part when you write derivative. So write differentiating with respect to x. So we will differentiate it with respect to x. It will be 1 over u du over dx. I think there is no need to tell you how it came because of the same calculation work you have done for y. And here product rule, first as it is derivative of log x is 1 over x, then plus log x as it is, in second part as it is derivative of x is 1. Cancellation is there. So you have du over dx equal to u into 1 plus log x, or in the end you have u means x raised to power x into 1 plus log x. So we have answer of du over dx we will fill here. Now for the time we will write now answer for this v also, means we need dv over dx. So I am going to start calculation work for this v. Let's see what will come from this v. Also we can say and v is equal to a raised to power x. Again the work is same, taking log in both sides. Right, log in both the sides, you will have log v equal to log of a raised to power x, which can be written as log of v equal to x log a. This power will come in front of log a. Now you have to write its derivative. So what will be the derivative? I will write calculation work in that side because of this equation. We need it to fill values in it. Okay. So I am writing once differentiating with respect to x. It will be here. Okay. So d 1 over v dv over dx. For this v equal to same first part, second part. First as it is, and log of a's derivative. It is yes log of a. Log of a constant value, derivative equal to 0 because it will be a constant answer. Okay, so constant value will be having derivative equal to 0. Then plus log a as it is, derivative of x is 1. So you have dv over dx equal to v into this value 0 plus log a means it is log a only, and it is this v. V is what? V is a raised to power x. So a raised to power x log a. So you have dv over dx also with you. So we have these two answers here with us. Okay. So we are going to fill them in equation 1. So I am writing put in 1. So I will put these values here in equation 1. So 1 is given here. So I am going to erase all these values and we will replace here. Okay, by their values. So du over dx is x raised to power x. Then 1 plus log of x. This will remain the same, ax raised to power a minus 1. Last dv over dx is here, a raised to power x log of a. This is the required answer of question number 10. So we will start now question number 11 after this. In question number 11 we have x raised to power x square minus 3 plus x minus 3 raised to power x square. So let's write in the same way. So I am writing solution of this. Let y equal to this given statement x raised to power x square minus 3 plus x minus 3 raised to power x square. Just give them name, u to the first value and v to the next value. You can mark say or we just imagined. Okay. Therefore, what about dy over dx? It will be du over dx plus dv over dx. Mark it as first equation. Now you have u equal to x raised to power x square minus 3. Taking log, same work. So we are writing log in both sides. So write log in both sides. It will be log of u equal to log of this whole x raised to power x square minus 3. Because of property of log, this power will come in front of this x square minus 3 into log of this inner value whose power was given, that is x. So there are two parts, 1 and 2. We will use product rule to find derivative. So I am writing differentiating with respect to x. It will be 1 over u du over dx as we did in previous part. Here first as it is into derivative of log x is 1 over x plus second as it is means log x as it is, derivative of x square minus 3 is 2x minus 0. So we have further calculation possible, du over dx, u into this whole calculation, x square minus 3 over x plus it will be 2x log of x. So we have this. Now further we can solve it. Okay. So we can write u's value. What is u? U is given here. It is du over dx equal to, u means x raised to power x square minus 3 into this whole x square minus 3 over x plus 2x log of x. So this is our first calculation, du over dx. Now we will write and v. What is v? V is here x minus 3 raised to power x square. Taking log, same work, log in both sides. When you write log in both the sides, you see it will be log of v and log of this x minus 3 whole raised to power 2. Then property of log will be power will come in front and you have log of x minus 3 inside. Mark them as first and second part. Now write derivative. Okay, so differentiating with respect to x, 1 over v dv over dx for this, and first part as it is x square, derivative of log x minus 3 is 1 over x minus 3, then derivative of this x minus 3 is 1 minus 0, then plus second part as it is means log x minus 3 as it is, derivative of x square is 2x. So we have this, it will be dv over dx, shift v there, v into, this is x square over x minus 3, then plus 2x into log x minus 3. Now fill value of v, v is what? X minus 3 raised to power x square, along with this whole calculation again. So I am repeating the same, 2x log of x minus 3. So they are two answers. It is dv over dx. So we have du over dx, dv over dx. Put these values in 1. So I am writing put in 1. Put in equation 1. And 1 is here in front of you. So we will use it. What is du over dx? Du over dx is here clearly marked. X raised to power x square minus 3 into x square minus 3 over x plus 2x log x. And plus dv over dx, it is given here, x minus 3 raised to power x square into x square over x minus 3 plus 2x log of x minus 3. So this was our answer of question number 11. See further what is given in question number 12 after this. Students, our next question number 12 is of another type which you have done already in previous exercises. That is, you have to calculate dy over dx if y given 12 1 minus cos t. This is in t, so we have to write derivative with respect to t for y. Then here x equal to 10 t minus sin t. This is also in t, so we have to write derivative with respect to t. But in that you need answer of dy upon dx. So you have to eliminate that t also from the answer. So see how to solve this. Okay, you have done already. Y equal to 12 1 minus cos t, and I am writing and x equal to 10 t minus sin t. Write the derivatives differentiating with respect to t in both. So it will be dy over dt equal to 12. What about derivative of inner value? Derivative of 1 is 0. Derivative of cos t is minus sin t. So it will be plus sin t here, minus minus plus. So in that you will have 12 sin t answer for this. Now what about this? It will be dx over dt, 10 as it is. Derivative of t is 1 and derivative of sin t is cos t. So it will be 1 minus cos t. So now we have this kind of calculation with us, but we will write dy over dx. Try to remember how you were marking dy over dx. It should be dy over dt upon dx over dt. So now we have both answers. Dy over dt is with us 12 sin t, and here you have dx over dt 10 into 1 minus cos t. Now there were formulas of double angle, sin 2 theta, 2 sin theta, cos theta. And if I replace theta by t, so sin t means its half is here, 2 theta's half is theta, so t's half is t upon 2. So sin t over 2, cos t over 2. Similarly, one more formula, this is 1 minus cos t or 1 minus cos theta is actually 2 sin square theta over 2. So if it is 2 sin square theta over 2, you have t here, so it will be 2 sin square t over 2. So we have to use calculations here. So 12 into, I am changing it into 2 sin theta over 2 means t over 2 cos t over 2. Similarly for the denominator 10 into, what about this? It is 2 sin square t over 2. So sin t over 2, one time cancelled, one time left. And here 2 can be cancelled with 2 and 12. 2 into 6, 12, 2 into 5, 10. So you have 6 over 5. Here cos t over 2 and one time sin t over 2 will be cot t over 2. So this is the required answer of question number 12. I think you are understanding these, you have done already, but still there is a need of practice, so give some time to these calculations to understand. See what is given next in 13th question of this. In question number 13 you have near about the same calculation as you have done in 12, Find dy upon dx if y equal to sine inverse x plus sine inverse square root of 1 minus x square. If directly we go for its derivative, that will take a lot of time as well as there is a difficult procedure. So for that, you can take help from concepts given in chapter number 2, inverse trigonometry. You can use replacement here for x. So let's see what we have to write here. Solution of this. So you have y equal to sine inverse x plus sine inverse square root of 1 minus x square. We will write put x equal to sine theta or theta equal to sine inverse x. Means if we shift sine here, it will be inverse of x. So we have this. Now see what will be next. We will write here replacement. So therefore y will be sine inverse x, we marked as theta, plus sine inverse. In the square root sine you have 1 minus x square. What is x? Sine theta. So it will be 1 minus sine theta whole square, which will give theta plus sine inverse. 1 minus sine theta square means sine square theta, or theta plus sine inverse. What about 1 minus sine square theta? It is cos square theta, or theta plus sine inverse cos theta cos square theta under root is cos theta. But we can't handle these two directly. We have to convert cos into sine. As you know, we already marked in lower classes so many times. Sine 90 minus theta is cos theta. In other words, cos theta is actually sine 90 means pi over 2 minus theta. So we have this change. See, sine inverse and sine, they will get cancelled. So theta plus, what is left with you? Plus pi over 2 minus theta. Theta also cancelled. So we have pi upon 2. So y equal to pi over 2. Now you can find easily the derivative. Therefore, differentiating with respect to x, this will give dy over dx equal to derivative of pi over 2 means 90 degree, that is constant value, equal to 0. So we have this answer of question number 13. I think easiest one, just remember this replacement. It will be very easy then. See what is given next in question number 14 after this. Students, our question number 14 is another important question for examination. See what we have to do here. If x into square root of 1 plus y into square root of 1 plus x is equal to 0, for this minus 1 less than x less than 1, it is only a condition. Prove that dy upon dx equal to minus 1 over 1 plus x raised to power 2. So you have to remember, very important question for examination. Let me start its calculation. We have given with this only x 1 plus y 1 plus x in the square root equal to 0. Directly there is no value of y given, so there is a need of some calculation. First of all, shift this to the right side. It will be x into square root of 1 plus y, then minus of y into square root of 1 plus x. Still there are square roots. If we handle these directly, there will be some kind of difficulty. So we will write squaring both sides. We will write their square. So squaring both sides will give square of the left side means x into 1 plus y square root raised to power 2 minus y square root of 1 plus x raised to power 2, which will give us square of x. This square root will eliminate from 1 plus y, and here y minus square plus sine y square root will eliminate from 1 plus x. Then multiply these x with both x square plus x square y square plus xy square. So we have this kind of calculation. Combine these two similar values in the left side. You have x square, shift y square, it will be minus of y square. And this number, this value we will shift to the right side. It will be xy square of the right side and minus x square y. Here you have a square minus b square type. So we can use formula a plus b into a minus b. Similarly here, try to take some value common if possible. What will be common? You can take xy common. So xy common will give y minus x here. But they are different. Here you have x minus y, in this you have y minus x. So let's make them equal. First left side will remain the same, but right side is having minus common. When we take minus out, it will be minus xy into x minus y. Change their order and the sign in between. So you will have minus common in these two. X will come first and y after that by changing the sign. So you have this cancellation possible. X minus y will get cancelled. So you have this. Further, you have x plus y equal to minus xy. So combine similar values. I am going to combine this here in left side. So it will be x plus y plus xy. So here you have plus sign for minus xy equal to 0. From these two you can take y out, 1 plus x, and x as it is equal to 0. Now you can keep y in this side, so y into 1 plus x in the left side, and when you shift x to right side it will be minus x, and lastly y equal to minus x over 1 plus x. So we have this y, but still we need answer of dy over dx. So we will differentiate with respect to x. So dy over dx. Try to remember quotient rule. Square of the denominator. So 1 plus x raised to power 2. Then derivative of numerator first. So numerator is minus x. So derivative of minus x. Derivative of minus x into denominator as it is means 1 plus x. Then minus sign. Derivative of the denominator means d over dx of 1 plus x into numerator as it is means minus x. So you have calculation like this. I am going to write in this side because our requirement is we need answer like this, minus 1 over 1 plus x raised to power 2. So its solution is dy over dx equal to derivative of minus x is minus 1 into 1 plus x. Then minus sign, derivative of 1 plus x is 0 plus 1. Derivative of 1 is 0, derivative of x is derivative 1 is 0, derivative of x is 1. Then into minus of x over 1 plus x raised to power 2. Further, minus 1 will give minus 1 minus x here. Then minus sign, minus plus x over 1 plus x raised to power 2. And here you can cancel x. And you are left with your required answer, that is dy over dx equal to minus 1 over 1 plus x raised to power 2, hence proved. This was our question number 14. I hope all these questions are clear to you. Try to understand and try to write them once by yourself to understand these things. They are not tough, they need attention and hard work. So see you next time. Thanks for watching. Bye bye.